Okay, I don't know what happened, but I guess it got cut off, and at least I looked up and saw that it got cut off. So here's my circle. Here's a spinner. A portion of it is going to be purple. A portion of it is going to be green. I don't know which one, but I gave you a dead giveaway that the purple is probably going to be bigger than the green, since this one's really only 16%. Okay, so here's how we did this. We tried to do this the long way, and I was super confused. So then I said, okay, well, why don't we go back to what we do know, is that we do know spinners at least, right? I mean, not spinners. We do know tree diagrams, and sometimes it's easier to work this stuff out with tree diagrams than just trying to go at it from scratch. So I did, okay, well, here's a tree diagram. I'm going to hit green and then purple. So let's go with purple and then green. And then I know if I spin a green, right, and then I have another choice. It's the same spinner. It hasn't changed anything. Either I can get a purple, or I can get a green. Well, spinning twice right now, I can tell you green and green, spinning twice. The problem tells us that we get a probability of 16%, better known as 0.16. Okay, I don't know what the others are, but I'm pretty sure the others are going to be the same. So we either get purple or green, so we either get purple or we get the green, right? So if you spin a purple, you have a choice again to spin purple. What's the probability? Purple or green? Green, purple, green, and green. 0.16 is the probability of spinning green twice in a row. Now, if you don't remember what to do with tree diagrams, you usually multiply the branches. So what number times what number is going to give you 0.16? And the best way that I can say it is, it has to be the same number because it's the same spinner. The probability of the spin probability of landing on green has not changed just because you're going a second time. What happens is the probability of spinning green twice changes, but that's besides the point. So what number times itself, right, because it's the same number twice, gives you 16. So what number times what number gives you 16? Hopefully you're thinking 4. 4 times 4 gives you 16. So if that's true, which it is, 0.4 and 0.4, 0.4 times 0.4 gives you 0.16. So if the green is 4 or 0.4, or better known as 40% of your circle, that means purple has to be 60% of your circle, because 40 and 60 make 100. And again, in the next spin, 60% of your circle, and the green is still 40% of your circle. But purple times purple, because you want to know what's the probability of landing on purple twice, well, purple 0.6 times 0.6, 0.6 times 0.6 gives you 0.36. I should do that in black. 0.36, better known as 36%. So there's a 36% chance of landing on purple twice versus a 16% chance of landing on purple twice. There you go. That was 111. 112. The trapezoids are similar. What's the ratio of the heights? Hint, it's not 3 or 1 to 30. The ratio of the heights. It's 1 to 3. Why would it say 1 to 30? I don't know. Well, the height for this one is 11 centimeters, and the height for the other one is 33 centimeters. So the ratio of the heights is 1 to 3. Why would it be 1 to 30? I don't know. Well, it's 1/3. Or if you really want to say 1 to 3. Either way, it doesn't really matter. Okay, compare the areas. What's the ratio of the areas? Okay, so the area for the small one is, what is this? So formula for the area of the trapezoid was height times b1 plus b2 all divided by 2. So the height is 11 times 20 plus 30 all divided by 2. So the area is 20 plus 30 is 50. So 11 times 50. divided by 2. So I don't know what 11 times 50 is, but I could probably do 25 times. 11 times 50 is 500. Wow, that was so lame. Divided by 2. It's 275. Okay, so this has an area of 275 centimeters squared. The small one does. Okay, and then the big one. Okay, I guess I gotta multiply by 3. So 20 times 3 is 60. 30 times 3 is 90. Alright, so area of this trapezoid is the height, 33. 60 plus 90, all divided by 2. 33. 60 plus 90 is what? 150. Well, 150 divided by 2. So 33 times 150 was 4950 divided by 2 is 2475. Okay, so the area of the big one is 2475 centimeters squared. So the small one, 275 over, so the ratio, sorry, that's what I'm doing. Area of the ratios, no, ratio of the areas, wow. 2475, is that divisible by that one? Divided by 275? Ooh, it is. Hey, look, it's 1 to 9. Awesome. Oh, and that should not be a coincidence since, hey, that was the ratio for the linear part. 1 to 3 was a linear ratio, so that means the area has to be 1 to 9 because 1 squared is 1, 3 squared is 9. Awesome. Cool. All right, 113. The most interesting function ever, or the most interesting problem ever. You have functions are added again. There's another race to infinity. Yay, we have more contestants. The functions are g of x, so 10x squared. There's the g of x. H of x, which is 0.01x, there's your exponential, are both in the race. The third mystery function arrives with the values shown in the table, so they're also in the race. So this is the third function, and I'm going to do this one in green. I don't know, function. I guess we could GH, we can call it, I don't know, we can call it f of x because we're not really using f of x in this one. There's your table of values. And then, so it does not get to the starting line until after the race has begun. Well, that doesn't really tell me. I don't know. So substitute an x for the three functions. Which is the greatest? Well, I don't know how you're supposed to substitute if you don't really get the equation, which is funny to me because I think in part C it says write the possible equation for the mystery function. Like, what? I guess you're supposed to just keep on doing the table? That sounds lame. All right, well, this looks like it's multiplying by 2, if I'm not mistaken. Yeah, because they're just doubling every time. Times 2, times 2, times 2. So since it's multiplying, it's a geometric function, which means it's going to have an exponential parent graph. So it should look like 2 to the x, and their starting value is 0.01. So 0.01. Okay, so there's your function for the table. All right, so now the question is, plug in 10 for the x for all three of these, for the blue one, the orange one, and the green one. Which one of them has a higher value at x equals 10? And if you do it correctly, I think you should end up with the quadratic being the highest one, if I'm not mistaken. Yeah, I think the quadratic is. If you plug in 10 for this one, 10 for this one, 10 for that one, the quadratic, I think the blue one has the highest value. Okay, so the next question is, how fast is each function going during the first 2 seconds of the race? That is, what's the average rate of change for each function for the interval from 0 to 2? So the average rate of change, well, this isn't very helpful because now I actually have to do a table of values. So 0 is 0. 1 is, 1 squared is just 1 times 10 is 10. And then 2 squared is 4 times 10 is 40. Okay, there's the blue one. Where's the orange one? The orange one, oh my goodness. 0 is 1. 1 is going to be 1.01. And 2, I have no clue. 0.01 times 0.01. Oh, wow, that did not really go that way much. 0.2. Okay. What's the rate of change for those three? So you're going to take the points 0 and 2. So for the first one, we went up 40, right? So 40, but over a time span of 2 seconds. So 2. So 40 divided by 2 gives us 20. Are we have any units in this? Okay, so your rate of change is going to be 20. 20 what? I guess 20 per second. 20. There's no units on here. Okay, whatever. 20 units per second. That's not very helpful. Wow. How do they have seconds as a units for the x, but they don't have any seconds for the y values? Well, this is a very bad problem. Okay, so 20 units per second on this one. This one went up 0.00. This one went up from 0.00 to, I'm sorry, from 1.00 to 1.02. You went up 0.02 over a span of 2. So 0.02 divided by 2, you go 0.01 per 1 second. And then the next one, the green one, the rate of change is from 0.01 to 0.04. You went up 0.03 over a time span of 2. 0.03 divided by 2 is going to be 0.015 per 1. Okay, so I guess I was right. The blue one actually goes much faster in the first 2 seconds, so that's probably why it's in the lead at the 10. All right, so write a possible equation for the mystery function, which we did. That's an exponential. You're multiplying by 2. Your starting value is 0.01. Which function will eventually win the race, and when will it take the lead? Okay, now, this is where I bet Matt Cordero, sorry, I bet Matt chicken wings, and I won, needless to say, because he thought it was going to be still the blue one, and I was right, so he owes me wings. Okay, so here's what it looks like for the first 10, right? And I'm going to zoom out so you can see a little bit better. So here's a quadratic. Here's the blue one, right? And there's the blue one. Yay! Okay, kind of goes up like that. This is the orange one. I'm pretty sure this is the orange one, if I'm doing this correctly. All right, and it goes off in that direction. And then here is the function in the... No, that was the green one. I lied. Shoot. Okay, this was the green one. My bad. Sorry, you're going to have to pretend that's green. This is the green one that I did. This is the one we had to come up with our own equation for it. And then this is the orange one. Okay. Now, obviously, it's not a flat line. Obviously, it's not a flat line, but right now it just looks like it is because the numbers are so small. But something's going to happen when you make the scale a little bit bigger. So there's the blue one. Obviously, that's winning because at 10, it's like really, really high up there. Green one, and then the orange one. That's at when 10 is at. So 10 is going to be like high up here. Blue is going to be really, really, really high up here. Okay, so here's what happened and why Matt lost the bet. Because I said exponential always wins over quadratic any given day. And I was right. So what you can't see is actually the green one winning over here. Here's the green one. It's really dark. There's the green one. Here's the blue one, because this really was a tie between orange and green and blue. Here's the blue one. I'm going to do it right next to it. Okay. So the blue one eventually is actually overtaken by the green one, because somewhere down here, and it's obviously less than 500, and I almost want to try to see if I can figure out where it's at. Somewhere less than, is it 100? I'm going to mess with the values really quickly and see. 100? No, the green's still winning there. When does it overtake the green? All right, well, eventually the green one overtakes the blue one. I'm trying to figure out where, though. Let's go with... No. 500? Oh, almost. 1,000? Ooh, almost. Alright, somewhere around 3,500, I think, if I'm not mistaken. So somewhere around 3,500, because this is like, 25,000. Somewhere around 3,500, so somewhere over here, the blue actually loses its spot, and the green actually takes over. So, that's what it looks like. Yay. Alright, I'll see you guys in class.